In this video, we are going to learn the basics of normal distributions. First, let's review what it means to be a distribution. In this case, we're talking about a probability distribution. So what that means is the distribution shows the possible values of your variable, which is usually noted by x, and also the probabilities associated with each of those values. So that would be p of x. Now, the normal distribution is a special type of distribution, and there are a couple things that make it special. First of all, the normal distribution works with continuous variables. So those are variables that can take on an infinite number of values. So for example, height would be a continuous variable, or temperature, or also distances are continuous variables. That's because, for example, with temperature, there are an infinite number of possible temperatures. Even between just 80 degrees and 82 degrees, there are an infinite number of numbers in between those if you're thinking about all the decimals. So those are continuous variables. The alternative to continuous variables, remember, is something called a discrete variable. And that's a type of variable that only has a finite number of values. So for example, the number of people in a classroom. You can't have 1.5 people, you can only have whole numbers, and there's going to be a certain range that you can have, so that would be a discrete variable. So normal distributions work with continuous variables, and that's the first thing you need to know about them. The other thing you need to know is the shape that they typically take. The best way to think about a normal distribution is by its graph. And a normal distribution is special because it's centered around its average value. And if you were to plot the probabilities for all the different possible values, it will look like this, where the average value is right in the middle. So the highest probabilities are at the average value. One other name for a normal distribution that you might have heard is called a bell curve, because some people think that the normal curve right here looks sort of like a bell. And again, what makes it special is that the normal distribution, or the bell curve, is centered around its middle. If you wanted to figure out if a curve or a set of data was a normal distribution, what you would want to do is plot your data into a graph so that you could see the shape it took on and see if it looks like this. If it has this general shape, then it's likely a normal distribution. If it looks like something completely different, then it's probably not normal distribution. There are a lot of things in nature that actually are normally distributed, like height, for example. Most people are at sort of an average height, and as you get taller and taller and taller, there are fewer and fewer people that are very tall. Similarly, in the other direction, as you get shorter and shorter, you find fewer and fewer people who are that short. Most people are sort of somewhere in the middle. And that's the whole idea with normal distributions.